we are dividing. So BTP sessions are there, and we would be okay. What did just happen? Yeah, we would be having some sort of configurations that we would be doing. As a part of the configuration, we have multiple things. First, let's just say sub account. That is something we would be seeing. We have a database component. We do have a service, or I can say, yeah, external service subscriptions model. That is something that we would be seeing. We would be starting with our application developments as well. That would be using CAP, and we would be preferring Node.js because that is what SAP is recommending. And I don't want all of us to actually jump from Node.js to Java and Java to Node.js. We'll be focused on one technology because the architecture is same. Let's just first understand the architecture, then language is not a barrier. We used to learn C, C++ in our initial days, then we jumped to ABAP, and then we are now into Node.js, and we would keep on growing like that. Using the CAP, we would be generating the backend services. So what ideally an application contains? When I think of an application, ideally it contains an application ideally contains a platform, or I can say a infrastructure. Infrastructure would need kind of an operating systems and everything, post which it would have a database component. It would have some sort of application server. It would have some sort of UI. So this all builds my modules. Okay, see, this all builds my modules, post which we would be having let's just say some sort of external resources. Because we all know a person alone cannot do anything, or I can say a person alone can do something, but to certain extent. For him to grow, we need to build a network. Same way, for an application to work in a versatile way, for it to be connected, we need some sort of openness. So these all the properties which I'm writing over here has something to do with the BTP architecture. Okay. So the openness being one of the thing. If I'm talking of the modules, then these are the DB application server UI modules. We would be having, as a part of openness, we would have a integrations with third-party application. Okay, we would have a integration with third-party applications. Those third-party applications we would be connecting using something called resources. And this all the resources we would be able to connect because the application development platform which BTP is providing is a MTA based. And by MTA based, I mean it's a allowing us to create a multi-target application. When I say multi-target application, it can have multiple sources. It can have multiple resources from where it can consume the data, and it can give the output. It can behave as a backbone for the multiple application, though they are running separately. You can think of a banking domain. You can think of a banking service. A banking service ideally would provide an API. I have muted all of us just to avoid any sort of disturbance. You can unmute anytime in case you have any doubts. Okay. So banking service being one of them. Banking service is working standalone, but it has a kind of a architecture which is giving us all the methods, all the endpoints that any application which is requiring to consume its service can connect easily. And that is only possible once you have an application with an architecture of MTA. Okay, we would be seeing this. Just be with me because it's not an ABAP where we just have a reports, or I can say some sort of objects. It is a project-based development, totally project-based development. Though those who have worked with a Fury development, UI development, would be able to easily correlate with this some or more. Okay. So we would be learning the CAP, Node.js backend services. Then using the CAP as well, we would be generating the UI apps. So mostly we are not going into core UI application development. Instead, we would be developing it using CAP architecture because we are not here to learn front end. We are here to learn what CAP is CAP is capable of doing out of box. So mostly it would be no code, low code based. And wherever required, we would also be learning extra logic that we can write, because generic being generic is a good thing, but our all the business heads has some sort of deviation that cannot be achieved using the generic sort of development. Post which we would be having this UI application. So it would give us a UI, or in terms of BTP, I can say HTML services. We would be connecting those with the user access services, and those user access services would allow us to authenticate individual users, saying only authorized set of people would be able to use my application. Then we would be proceeding with the deploying, or I can say deployment of the application. And we would be seeing these applications are now available in the for the real use. So as a part of service subscription, we do have multiple one. BAS is something that we would be using the most. We do have some sort of external database like just a PostgreSQL. Uh, then we have let's just say some sort of logging service as well, some sort of workflow management. We would also be seeing how cross team can work together. So we would have some sort of GitHub, um, I guess, introduction to some sort of GitHub architecture. It won't be that huge because we know GitHub is something that we all have started working already. Okay. As a part of this session, let's just start with the basics that we need. So we would be first learning the cloud native architecture, its working mechanism, and all this particular component. And lastly, we would be setting up the BAS Business Application Studio, or I can say I'll be setting its workspace, dev workspace for the actual application. Perfect. Now let's just learn the BTP architecture, or I can say cloud native architecture first. It would seem some sort of a theory, but it's not a theory, it's a history. Why actually it came into picture? So we have a cloud native. Any one of you would like to tell me what is the difference between a on-premise and a cloud system? Anyone? A short one. Just to know we all are awake, we all are here. Okay. So
Cloud is user based, right? I mean, it's
kind of.
User specific. I mean, whatever. I mean, if you want to use a service, SAP is offering that. I mean, cloud. I'm not. I'm saying generic thing. As a
But
service, it is offered, right?
yeah, definitely it is providing services, and it is providing services in different way. So something as a service. You might have
Yeah,
heard of
so cloud has, I
ESS.
believe, three: IaaS, PaaS, and SaaS: infrastructure
Perfect.
as a service, software as a service, platform as a service. So when a
Okay.
company goes for infrastructure as a service,
Hmm.
so the company would be, or the client would be provided with the hardware and software infrastructure till the security.
Perfect.
The platform and the data is always with the client. The platform and the software will be that of the client again if the client goes for us. If the client goes for PaaS, that is platform as a service, so infrastructure and platform are included mostly, and the data and software would be part of client's side.
Perfect.
And if client goes for SaaS, I believe the data has to be that of client. The software platform and infrastructure will be provided by the cloud company.
Exactly.
And
So it seems like we are going with some sort of subscription. Whatever we
subscription,
need,
right?
we can just subscribe that. Perfect.
Right,
Exactly.
right.
How and what
I
would
have
be there?
I have just
Yeah, yeah,
one question,
yeah,
Sumit.
please.
Uh, can like do like if I am going out from on premise to
Yeah.
cloud.
Hmm.
So would I be creating an infrastructure for cloud? Like from client perspective, the client
Hmm.
is going from on-premise to cloud. So
Perfect.
would the client think about creating their own cloud, or they go for subscription? I'm not aware of this part
So
because
so there are two sort of cloud technologies: public cloud, private cloud. Some there is also a terminology coming as a hybrid cloud. So public cloud is a kind of a cloud technologies, or where there would be a data center, but that won't be dedicated to one client. Instead, you would be purchasing or subscribing for a space where only your application or I can say only your client relevant information would be stored. But in that same data center, there would be multiple subscribers information, subscribers application would be running in that particular infra. Many a time, whenever there is a very much data sensitive, or let's just say some sort of very sensitive informations, those need higher amount of security. Definitely cloud is also providing a security. But if I think of a sharing, what a sharing means you can think of a data center as your laptop. If I have my laptop where I do have only one application running, all my operating systems capability, firewall, everyone would be dedicated to that one application. It would work the more smoother way I can any time expect. But when I have 15 application installed in it, the operating systems capability to actually serve those would be splitted. So many a time, if I want a high performance, many a time when I want a very high amount of security, people go with a private cloud. So it depends on the use case, how sensitive, how I can say important it is to have the service live, available, and up to the speed. Because cloud has kind of multiple users when it comes to public cloud, and that might you might observe some sort of sharing in the resources, and that might result in some sort of performance deviation. And that is why uh, there are two options. Depending on your use case, you can choose one. We will be going deeper into that. Don't be confused. Don't worry. Okay. And yeah, when I talk about on-premise, okay. So Ellen has explained very well what is a cloud. When it comes to on-premise, it's a kind of a setup where everything is being owned by that particular client, or I can say the person who is actually um, asking for that service. So for example, I want my internal network, I want my data centers, firewall, security, everything is something that that particular um, organization who is using that particular, I can say application, or I can say, let's just say I am going with one SAP box. If it's on premise, I would have internal data centers. I would have my internal infrastructure team who would be handling what all patches to be installed, what all updates I have to actually do by time, all the compliance and everything. That particular organization who is using that has to bear all of them, and they have to be compliant, because compliance is very important when it comes to IT system. Okay, so with cloud, you are ultimately handing over that responsibility and focusing only on what your business needs, because rest everything is actually borne by the service provider. Perfect. So I hope you would have heard of one term. I'm not sure what are we well aware of that, but let's just say there used to be some sort of monolithic applications. There used to be a term called monolithic applications. When I say monolithic application, what does it mean? Let's just say I do have a big application over here. And here I do have a login service. Here I do have, let's just say logger, where my all the application logs are getting logged. Here I do have some sort of reporting services. Here I do have some sort of transactional. Let's just say I am getting all the uh, purchase requisition contracts and everything, whatever day-to-day transactions are there, those are getting reported. Okay. And here I do have some sort of, let's just say email services, where as a part of which all the emails are getting shoot based on whatever notification, or I can say some sort of notification service you can think of. This all is built, okay, in a, I can say if I do have a monolithic application, if my an application is having 5 functionality hypothetically, then all those 5 functionality would be part of a single binary. And binary, I mean a single program, a single object that would be having all this capability, all this functionality written as a part of that. When there is a requirement, when there is a bug, or where there is a change in a logger service, let's just say, for example, hypothetically, that logger service has some sort of gray area that needs to be worked on. So we are doing some sort of changes in the logger service. We have fixed that. But when this particular service would get transported, would get migrated from the dev system to your dedicated production system, we can expect some sort of service outage over here. And it's not dedicated to logger service. This logger service is a must to have component for all this application. And is it's a 1,000 line of code, out of which line number 50 to 80 is having the logic for logger service. It means I am transporting my whole object. And if I am transporting my whole object for some amount of time, be it microsecond, milliseconds, or depending on the size of the application, there can be a few minutes or hours of outage that we can expect. And that sort of outage would result into some sort of production work outage. IT is a backbone of all the business. Okay, but IT is not something that we are selling physically. It should not hold a carrier. It should not hold a truck to get transported, right? And that is why if there is any sort of service outage, it would result into some sort of monetary loss. But this is what a monolithic application was having. So each time we used to decide whenever I'm going with a rollout, I used to have some sort of system outage. To avoid that, cloud technologies, or I can say the application developer come with some sort of modularization concept. And that modularization concept is called a microservices. Microservices says, okay, you do have an application called, let's just say, material management, for example. Okay, this material management application, the whole related functionality that it is handling has a functionality for authentication and all this. So I would have an application which would have multiple resources, which would have multiple services it would be connected to. Okay, in case of any sort of change or upgrade in this dedicated service, I can expect only this service to get transported because this is a separate service first. Second, it may or may not be handled by the same team. There would be dedicated one team who is working on dedicatedly logger service, and they are providing this service for 15 odd applications. For email services, there is also one more dedicated team who is working. So those all microservices are actually handled separately. We have just referenced it over here. And that is why it is called a microservice. It is a separate service which is being consumed just because we want that service in our application, but it's not part of our application. We have just connected to that. So in case of any of the change, I'll just be updating this. My earlier application would keep on working as it was. There won't be any sort of system outage. No downtime would be required. Perfect. Now, in a cloud terminology, there is a concept. Okay, let's just go line by line. What used to be there in the earlier days? In the old days, what used to be is, let's just say we used to have some sort of dedicated, let's just say infrastructure, saying I want one application for database storing. I want some sort of media or add number of applications I used to have. So let's just focus on the first part first. So this particular for application, if I need, I used to have an infrastructure. Now this infrastructure, I can think of a RAM memory, CPU usage, some sort of security, or I can say some sort of firewall settings. Everything used to be there. And this all build my infrastructure. This is how the old days would look like. It used to look like. Okay. Now, after having all this component, if I do have all this in place, along working on my application development, and I can dedicated application working on running on that. Now, let's just say I do have a small image viewer. A small image viewer, how much amount of memory it would need? Yeah, memory, I think it would need a higher one. But how much amount of RAM it would need? It would be working with a smaller one as well. That would be fine. CPU of a low configuration would also be fine. Likewise, we have a setup. We have a proper requirement of what all infrastructure that we would be needing. So if earlier we used to have 4 such application, we need 4 such infrastructure. Dedicatedly for one application, if I'm choosing, should I choose a infrastructure, a system with a lower configuration or a medium or a higher? So what ideally we used to do is initially while I'm building the application, definitely a lower one would be fine. But going forward, I might end up with a huge amount of data, huge amount of, let's just say audience base, then I might need a huge amount of capability as well. So let's just say I don't want to go with low configuration, instead just go with the higher. That's what a let's just say infrastructure setup team would finalize with. That okay, I would go with a higher configuration. But what it is costing? You see, if I say, okay, give me the best operating system, highest amount of RAM, highest amount of CPU, it is ultimately costing us a huge in the term of cost, right? Even though that is not an application which might need that amount of, let's just say infrastructure setup on the initial or in the final days as well. But from a safer side perspective, the people are investing on the higher configuration and which is costing higher to maintain the infrastructure used to be there in the older days. Perfect. So what happened is, you might have heard of an organization called VMware. VMware came up with a concept of a virtualization. What they told is, I do have a system which is having the highest amount of configuration. On top of this, let me just help you build some sort of virtual component. Let me help you build some sort of virtual system. You might have heard of the same terms earlier, that we used to have some sort of virtual system running. And let's just say in our college days, when we used to do some sort of application development, we used to have some sort of such virtual machines running on our system, where we used to install a dedicated operating system. You can think of a scenario where you do have a Windows system and you want to run a Linux. How you can do that? For that, we need some sort of virtual machine, and this virtual machine was being provided by VMware. So from there, a concept of virtualization came, that though I do have one system, I can have multiple components dedicated to that. Now, if I am saying that I do have 16 GB of RAM over here, I do have a 16 GB of RAM over here, but out of which for this application, I want to dedicate only 4 GB. And for this virtual machine, which I am creating, I want 8 GB of RAM to be allocated. I want a Linux to be installed over here. I want, let's just say, iOS to be installed over here based on my whatever requirement is. It would seem okay, rather than having 4 different machines, 4 different infrastructure for having the same, let's just say 4 applications to run. Instead, I can also settle in one application. And this was like a boom in the market, that okay, now I don't, the company don't need to pay 4 times if they want to go with a 4 application. But what used to happen is, if there are 4 applications which are running and there was a dedicated server, we came up with a concept called virtualization, where the virtual machine would be running. They would be having a dedicated amount of CPU assigned to them, server assigned to that, RAM memory assigned to that, splitted based on the total. That okay, I want 2 over here, 5 over here, and likewise. Operating system, whatever is needed, would be assigned over here. But what we are ending up with is 4-time license cost of operating system. The admin has to actually do the controlling, patching, update, antivirus, everything is needed for all these 4 boxes. Even though we do have a single infrastructure, the maintenance cost is ultimately potentially increasing. The maintenance time is increasing. That is one thing. The costing is something, let's just say, think, okay, this is an unavoidable task, we will do it. But what other thing it is hampering? I do have a server. you can think of a server saying I do have a huge capability of a server. One task just started working. That was the first one who actually kick-started its process. So it was fine. It was working smoothly. Going forward, second process just started its processing. As first task was working, it was getting some sort of delay, lagging in the response. You can think of a boot time, execution time. As it's connected to the same server, it is not performing up to the mark as it should be. So this virtualization concept was no doubt far better than what we used to have compared to the dedicated system. But this virtualization concept also was hampering to some extent, okay, because it requires all this sort of maintenance. Other than that, we also need to have some patience, because the load of this particular, let's just say, individual system would take a huge amount of time. You might have experienced that on your own as well, right? We, in our college days, in our, let's just say, some sort of local project that you might be doing, you might have done some sort of VMware installation. You might have gone with some sort of virtual machine installation, and you might have used the application. It used to take a huge amount of time. So think of an industrial application, how it would actually run smoothly in this environment. Then came up a concept of a containers. And this is a concept which is still there into the market. You might have heard this. There is a term called containerizing an app, containerizing an application. This is a still an ongoing, and this is the new future. Containerizing the application. We would see that in BTP, we do have a concept of containerizing as well. We are containerizing the backend service. We are containerizing the DB service. We are containerizing the UI service. These three are working in separate containers. Now, what is a container? A container, you can think of let's just say, if I think of a container out of the context of IT, what is a container? A container is something which is containing something. So this is a container which is containing my backend application. Now, for my backend application to work, it would need some sort of runtime. In terms of BTP, we do have multiple runtimes as well. The CF and KYMA. We would be going into this shortly. We would be learning CF and KYMA. Maybe not today, but in the upcoming sessions deeply. But these are the runtime that we would need. And this sort of runtime would be part of each of the containers, which would provide them the environment, which would provide them the operating system, the security patches, which would need them any sort of processing, a CPU usage, whatever they need, whatever command, or I can say controller they would need, that would be provided by that particular individual CF, or I can say KYMA runtime, and that would help the individual containers to run. So having this failure of a VMware, or I can say this virtual concept, concept of containers came into picture. So for handling, let's just focus on the left hand side first. For handling multiple virtual machines, we used to have some sort of hypervisor. Like we do have a supervisor, let's just say in a class. Same way, hypervisor is a term you might have heard of these days. When the cloud was very much into this discussion, that there is a hypervisor or hyperscaler you might have heard of. So those all the things are there to actually monitor and control the activities which are going on, and to handle multiple activities to coordinate with each other as well. So this hypervisor is monitoring all of this, and this is how this VM functionality used to work. Post which a concept came called as a containers. As a part of container, what used to happen is we are now having a operating system which is a single one. Instead, container came up with a concept of splitting the operating system itself. Rather than creating a virtual machine, let's just split the operating systems in a way that they can serve all its dedicated application. And that split is called a, I can say, a container. So that split is not a kind of a split which is having only a fixed amount of space. I don't need 4 operating system. Here I need 4 physical operating system. Instead, I would need only 1 operating system, 1 server that would be splitted based on ad hoc basis, whatever requirement came for that particular application. And that particular container would be dedicated to one application. So for example, my container would be dedicated for backend, DB and UI. This DB's purpose is to work on the data level. So whatever capability is required, container would be helping it to run. Okay, so we are able to overcome the issue, or I can say the limitation of a splitting of operating, or I can say replication of operating system, replication of individual system. Instead, we are splitting it. Okay, we don't need 4 times. We need only 1 time, but we are just splitting it based on how much is the requirement. Okay, and that splitting is occurring at the Linux, or I can say any sort of operating system level, and that is why it is called operating system slicing. So we are slicing the operating system, and that slice of our operating system is called a container. And these containers then created a kind of a new future, and then came a concept of a Docker. You might have heard of a Docker. So if you visualize this image, what it is a ship, or I can say a person, or someone who is handling the containers. What used to happen is, let me just give you a context. There used to be a company called .cloud that came into picture. The .cloud purpose was not to do what it is currently doing. The .cloud came into picture because it was trying to provide a service somewhere back in 2013, when it was thinking that let me just have some sort of infrastructure service from Amazon. So it was getting some sort of infrastructure, and based on that, it was providing developer experience. It was providing online developer experience on the cloud to have everyone work on their development remotely. A kind of I can say a VPN, because in the VPN you are using your local system infrastructure itself, but anytime we do have online compilers and everything. So that sort of online developer platform .cloud was providing some time, I guess sometime in past. Now that concept was not working too much, or I can say their business was not working too much. So what they came up with a concept of is a Docker. How it becomes is, how it actually came into realization was, for them to run their business, right? For them to run their business, they would need a developer experience on an Amazon cloud. For them to give the capability of having a developer do their activity on a cloud, they would need multiple containers. As a part of one container, one developer would be doing his activity, he would be developing his application, another developer would be doing his application activity, he might need multiple containers. Likewise, they are handling the container. They are starting, stopping and deleting the container based on whatever the requirement needs. Let's just say I am a developer, I am doing some sort of application development. I started working on that. My application is running. I initiated the process. It starts some container. It provided it with the infra. It provided it with the memory, CPU usage, whatever it needs. But then it realized that this sort of management of the container was not being provided by anyone. Containers were getting generated, but when to start a container, when to stop, when to delete. Now, when to start a container? When someone starts working on that. When to stop a container? When there is a process which is no longer needed. Okay, and there are some process, or let's just someone unsubscribe for that, then we have to delete the containers. Let's just say we do have a, let's just say some sort of system server outage. Then in that case, we have to create a replica of that container as well, because the process should still work. A container is failing due to some sort of infrastructure outage or something, but then also it should work. So that sort of container management, or I can say low level container management of how the containers would be interacting with each other when I can spawn new containers. That sort of concept was introduced by a Docker. And Docker, you would be hearing it in the cloud technologies very much, I guess many a time, that Docker is something still in the market, which is ensuring all the application images are loaded and running in a dedicated containers. Okay, a Docker can help you spawn 5 containers, out of which, let's just say 2 containers are getting killed due to some sort of overload, memory overload limitations, or let's just say due to n number of other reasons. Then that sort of handling is being done by Docker. And in the parallel universe, there was one more concept going on that was introduced by Google. And this Google introduced a concept called Kubernetes. What is a Kubernetes? If you see its picture on the top, what you can recognize over here is Kubernetes is nothing but a person who is handling a big ship, a kind of a helmsman. Okay, and that's why its symbol is also the same. Now K and S has 8 letters in between. That's why the concept called as a Kubernetes. It's a K8 set. It's that sometimes it's also called as a K8s. So this Kubernetes is handling. So you can think of a Docker which is handling the lower level, which is handling a lower level of a application processing. It is assigning them containers, allowing them to work. But to schedule when actually the container would be assigned, when it would get killed automatically, in case of a updation is required due to some sort of security patches, who would be doing that? Let's just say in case of n number of outage, or let's just say, okay. So Kubernetes, let me just go one more step forward. I guess that would be the, on second last one. Then we would have nothing on this particular theory concept. But just be with me, because SAP is growing. We would be into cloud, but when you are jumping into cloud, what you are opening for yourself, what kind of doors you are opening for yourself. We are not natively working for SAP then. You would have an opportunity to actually jump onto the native cloud, and that would help the other doors also for us. Okay, so this Kubernetes is an open source project till date being handled by Google, and you can also contribute on this. That is why it is called open source. There are plenty of people who have actually contributed in that. So like we have a in a Docker, we do have a container which is handling. Same way, Kubernetes has a concept of a node. Okay, consider I do have a application which is saying I want 2 nodes to work for me. I need at least 2 nodes. Why I say 2 nodes? Let's just say I do have a backend service which is carrying a huge amount of service load, a huge amount of data it is handling, huge amount of let's just say customer base it is hitting the service. So I need 2 nodes. So 2 replica of my processing environment where I can run. So 2 node, you can think of a 2 particular running endpoint of a service where my service is running. Okay, and if my service is running over here, and suddenly the load of a service gets started increasing, then to have those workload, to have that requirement handled dynamically, it should also allocate a few more nodes to for that application to work smoothly. And that node allocation is being done by the Kubernetes. So Kubernetes has a 2 component. This component is called the K8s control plane, is nothing but a Kubernetes leader. Okay, and this is a worker node. So there are 2 nodes, a leader node. This is a leader node who is saying, okay, I am monitoring the application, and during the monitoring, I figured out, okay, the load is increasing suddenly. So I'll allocate 1 more node where this application again would start working. Everything and anything there from the runtime that it would need, it would copy the same runtime from its existing running node and create an exact replica. So the other person would never come to know in which node that application is running. He would feel, okay, as if I am running the same application, and he would be actually, but the application would start running in a separate node. And when the load would come down, it would automatically merge all the running node and keep to the least amount of node that should run. Okay, so this node would have a runtime. So this runtime you can think of again your individual Cloud Foundry or Kaima, right? And there would be a agent which would be saying, okay, this particular requirement is coming. This is a user's input, and based on that you have to react. And that reaction is something that this particular node would ultimately generate, and the applications, or I can say the user's request, would be served. In case there is some sort of outage as well, a node is getting killed due to something, due to some sort of infrastructure or overhead or any sort of processing, the exact replica of that running node at that particular point in time would be created, and it would just start working on the another node. So the user would never feel as if there is a service outage. Okay, and this all is being handled by the Kubernetes. So Kaima concept, let's just say we are mainly focusing on the CF, right? The Cloud Foundry. Kaima is a SAP's flavor of Kubernetes, you can think of. Kaima runtime. We would be going with the introduction of Kaima. We would be learning Kaima as well in the upcoming session. But the same concept is also coming into picture when we do have a Kaima. Let's just say I do have a backend application running. I need an email service. So email service is also being handled by some sort of other provider, let's just say, and it is running in a separate node. So this node would be connected. They would be communicating with each other thanks to these agents who are ultimately working over here. And one more, the main important concept over here is, unlike cloud technologies, or I can say unlike another provider who are only serving the cloud technologies, Kubernetes is working, or I can say Kubernetes can help you interact between multiple clouds and on-premise system easily. So Kubernetes is also handling the cloud technology, on-premise technology, anything. So let's just say if you do have a set of apps which are running on-premise, and suddenly, or let's just say in some day you figure out, okay, I now have to move to cloud, or due to some dedicated requirement you want to move to on-premise, anything could happen. Then if you do have a Kubernetes, then your movement, your migration would be way smoother, because it's the same controller, it's the same leader node who would just point your node, who would just transfer the processing of your node to the on-premise engine compared to the cloud engine. Okay, it seems to be a bit of high-level concept, but that is how the cloud is working. So we would be going deeper into that, then it would make a more insight. But that is why the concept of containerizing app came into picture. So if you now just go into flashback, earlier we used to have individual, then we came up with the concept of virtualization. Then we virtualize it, not physically, but virtually, using a concept of containerized container, and those containers are being handled now by Docker, and those Docker are now unseparable part of a Kubernetes, and that is what is now leading the cloud technologies.